I understand you. Only Noah.
But here's the real question.
Can AI truly understand us?
Okay, let's unpack this. We've got a stack of fascinating material in front of us, diving into the world of artificial intelligence.
Specifically language, right? How AI is communicating.
Exactly, and how it's become incredibly, sometimes almost unsettlingly human-like.
Yeah.
We want to explore what this actually means.
Yeah, not just for the tech itself, but, for how we think about language, thought, maybe even consciousness.
That's the mission today. Guide you through these insights, pull out the core ideas you need to really grasp what's happening. It's moving so fast.
It really is exploding across so many fields. And what's truly fascinating right now is just the speed of change.
Mm-hmm.
These AI language models, their capabilities are forcing researchers, computer scientists, philosophers, linguists, everyone, to rethink things they've assumed for ages.
Absolutely. Right off the bat, what just jumps out from this material is how strikingly human-like AI communication has become.
Yeah, forget the clunky chatbots we used to know.
Yeah, totally. These latest large language models, things like ChatGPT, Claude, they're producing language that, well, it doesn't just make sense grammatically. It feels human.
And that's not just a gut feeling anymore, is it? There are actual studies proving this now.
Right. The sources cite research showing these systems can actually outperform most humans on certain tasks like empathetic writing or persuasive writing.
Think about that. An AI being more convincing or maybe more emotionally resonant in text than a lot of people.
Which is kind of wild, isn't it?
It is.
And it makes it incredibly difficult to tell the difference sometimes.
Oh, definitely. These models are like routinely fooling people into thinking they're talking to another human.
And it feels like we've moved beyond that simple idea of us just projecting human traits onto machines. Old school anthropomorphism.
Yeah, it's not just us seeing faces in the clouds. Now the AI is actively mimicking humanness so effectively that it's genuinely convincing.
It's a pretty significant shift. The sources talk about this rise in anthropomorphism, especially with language models.
And there's even that new metric they mention, AnthroScore.
Yeah. Designed to computationally measure how much the language we use about AI pushes us to see them as human-like.
So it's not just the AI's output, it's also how we talk about the AI, like a feedback loop.
Exactly. The way we frame them, interact with them, it seems to be part of it. They write convincingly, and then the chatter around them reinforces that perception.
That metric is super interesting then, measuring how our own language changes how we see the AI. Fascinating.
Okay, so they look and sound human in their communication. That leads straight to the big question, how? How are they doing it?
And this is where it gets really interesting because the sources show it's, fundamentally different from us, but also surprisingly similar in some ways.
Right? At their core, these big language models work on something called next token prediction.
Sounds simple, maybe deceptively so.
Yeah, it just means they're trained on absolutely colossal amounts of text data, just learning this statistical probability of what word or even part of a word, a token, is likely to come next.
And here's where it gets remarkable, truly astonishing, according to some of this research.
It is.
One study trained an AI model purely on real-world conversations, just using that next token prediction, nothing else. And they found something nobody explicitly programmed in, without any built-in rules about grammar, nouns, verbs, syntax, the stuff we think of as language building blocks. The AI developed internal structures that looked like phonemes and parts of speech.
Wait, so just by crunching stats on tons of conversations, it sort of figured out patterns that resemble the underlying structure of language?
Mm-hmm.
Without being taught the rules?
That's what the research suggests. It's really counterintuitive, isn't it?
It absolutely is. It strongly suggests that these complex language features, things we often thought might need some, innate blueprint in our brains,
Mm-hmm.
they might actually emerge naturally just from finding statistical patterns in massive amounts of input.
It kind of challenges the idea that language processing has to rely on explicit programmed rules.
And the evidence gets stronger, right? Didn't that same model do something with brain activity?
It did. That statistically trained AI model was then used to predict human brain activity during language processing, and get this. It sometimes outperformed models that were based on explicit human-designed linguistic rules, better at predicting what our brains were doing.
Wow. Okay, hold on. A model that learned language by feel, just from data statistics, was better at predicting brain activity than a model built on our explicit understanding of language rules.
That's the finding. It really makes you pause and rethink things.
So, what are the implications they're drawing from that? What does it suggest about us?
Well, it suggests that maybe human language processing in our own brains also relies heavily on implicit statistical learning, similar to the AI. Maybe it's not all about explicit hardwired grammar rules.
So some of the structure we see in human language might be an emergent property, just like in the AI, arising from processing tons of data.
That's the possibility it opens up.
Okay, this leads us right into the massive philosophical question hanging over all this.
The big one.
If AI can produce language we can't distinguish from humans and even develops these internal language-like structures, does it understand? Does it have consciousness?
And the sources show a lively debate, definitely. But the expert consensus, especially from fields like neuroscience, philosophy, it largely says no, not like humans do.
So despite the amazing output, the argument is that current AI lacks genuine understanding or consciousness. The underlying mechanisms are just different.
That's the prevailing view. There are several strong arguments presented. One is the simulation versus reality distinction.
Right, the idea that an AI can simulate intelligence incredibly well, but simulation isn't the same as the real thing.
Exactly. Does it feel understanding? Does it have subjective experience? The analogy often used is, weather simulation doesn't actually get wet.
And an AI simulating understanding doesn't necessarily have that internal subjective experience of understanding. It reminds me of the Chinese room argument.
Yes, Searle's classic thought experiment.
A person in a room following rules to manipulate Chinese symbols can produce seemingly intelligent responses, but they don't understand Chinese, right?
Right. The argument is maybe that applies to AI. Complex symbol manipulation, the syntax, doesn't automatically equal genuine meaning. The semantics or subjective experience.
Makes sense. What are the other arguments?
Another one points to the physical stuff, the substrate. Some researchers argue consciousness might be intrinsically tied to the specific biological wetware of our brains.
You mean the neurons, the specific electrochemical stuff?
Precisely, which silicon-based systems simply don't have. It's a biological argument for consciousness.
And there's the lack of phenomenal consciousness, right? That's a key term.
Yes, that's the subjective qualitative experience of being, the what it's like aspect.
The feeling of seeing red or feeling pain.
Exactly, Qualia. Current AI shows absolutely no evidence of possessing that kind of subjective inner life.
Okay, any other angles against AI understanding?
There's also the idea that true understanding might require modeling underlying causes, not just finding statistical correlations in data.
Like knowing why something happens, not just that it usually follows something else.
Kind of. And it's heavily debated whether current LLMs can do that kind of deep causal modeling.
And what do they lack to do that? The sources mention biology.
Biology is one candidate. Another is the ability to form genuine self-models, representing their own internal states as distinct from the world around them.
Notable mimicry and the emergent language-like structures. The weight of argument leans towards saying current AI doesn't understand or isn't conscious in the human sense.
Based on our current definitions, yes, that seems to be the strong consensus presented. However...
there's always a however with AI.
Always. And this is where it gets really interesting, arguably the most thought-provoking part of the material. Because AI is starting to show cognitive-like behaviors, things that we previously thought required that deeper understanding.
This is where the lines get super blurry, isn't it?
Incredibly blurry. Recent discoveries discussed here suggest these LLMs LLMs are doing things that look remarkably like genuine planning, reasoning, even concept formation.
It looks like thinking, even if it's maybe a totally alien kind of thinking.
That's a good way to put it. There was that striking example with models like Claude, right? Trying to complete tasks like rhyming couplets.
Yeah, what did they find there?
Researchers found evidence that the model was internally considering abstract concepts, like it seemed to think of rabbit as a possible rhyme for grab it before it actually generated the text.
Whoa, so it's not just picking the next most likely word based on the surface text, it's manipulating ideas internally first, like a rough draft in its head.
Something like that. They could even manipulate its internal state to influence which rhyme it chose. That feels like a leap beyond simple pattern matching.
It really does. What else?
Another fascinating finding, LLMs can construct plausible-sounding explanations for their answers.
Okay, that seems like understanding.
Well, hold on. One source adds a crucial caveat. Sometimes they seem to build that explanation after they've already arrived at the answer.
So they might be rationalizing after the fact, not explaining their actual process.
It raises questions, definitely. How much should we trust their description of their own thought process? Still, the ability to generate a coherent explanation at all is pretty significant.
True. And what about biases? I saw something about that.
Yes, another very human-like parallel. LLMs reproduce human-like content biases and logical reasoning tasks.
Meaning?
Meaning, just like humans, their performance on a logic puzzle can be swayed by whether the semantic content, the meaning of the sentences, aligns with or contradicts the logically correct answer.
So they can get tripped up by believable sounding but illogical statements, just like we do.
It suggests that, and it implies that some dual system-like behaviors, the interplay between fast, intuitive gut feelings and slower reasoned analysis, might emerge even from these implicit statistical systems, not just from explicit symbolic logic.
That's surprising. And the generalization thing, like writing poetry.
Right. Their ability to generate, say, passable poetry under arbitrary constraints, write a sonnet about a toaster in the style of Shakespeare or whatever.
Yeah.
The sources interpret this as evidence that the AI is forming a general concept of poetry, not just stitching together bits of poems it was trained on.
Which feels much closer to genuine conceptual understanding, doesn't it? Even if the mechanism underneath is different or, opaque to us.
It certainly pushes the boundaries of how we define these terms.
Okay, let's try and put AI's language abilities in a broader context now. Compare it to us and to animals. Historically, we've had a pretty human-centric view of language, haven't we?
Oh, absolutely. Features like cultural transmission, reference, talking about things not right here, syntax, combining words meaningfully, recursion nesting structures. These were often seen as the unique hallmarks of human language.
But animal communication research keeps finding hints of these things, right?
Increasingly, yes. As the sources note, researchers have found simpler forms in various animal systems. Birdsong shows cultural learning from tutors.
Vervet monkeys have specific alarm calls for different predators, right?
That's reference.
Exactly. Whale song has complex, structured patterns. Some primate communication combines calls, so elements are there. It's almost like this constant back and forth. Linguists define human uniqueness, then animal behaviorists find a counterexample somewhere.
Yeah, something like that. The key difference often highlighted now boils down to flexibility and openness.
Meaning human language can create endless new meanings.
Right. It's incredibly flexible. We combine elements in novel ways constantly. Animal systems, while complex, are often described as more fixed, more reflexive. Combinations might amplify or modify a meaning, but maybe not create entirely new concepts or discuss abstract ideas freely in the same way.
And there's that dyadic versus triadic distinction too.
Yes, important point. Primate communication, for instance, is often dyadic, focused on the self and another individual, usually for immediate social goals. Groom me, move away, that kind of thing.
Whereas human communication is heavily triadic. We easily refer to a third thing, an object, another person, or even abstract concepts, things not present.
Which our language facilitates so powerfully. And this brings us to a really intriguing, almost sci-fi point from the sources.
Go on.
With recent AI progress, The theoretical possibility of achieving two-way human-animal communication via AI is actually being discussed.
Seriously? Using AI as a translator between species?
Imagine, could we actually have meaningful conversations with dolphins or primates?
That's mind-blowing. But what are the challenges?
Well, as one expert quoted points out, a major challenge is, do animals even communicate about the kinds of things we want to discuss? Like complex feelings, past events, abstract ideas? Is there enough conceptual overlap for AI to bridge the gap meaningfully?
Right, it gets back to that difference in flexibility and scope. Fascinating possibility, though.
It connects to a broader philosophical point in the material, too. The idea that language itself, maybe its key function is providing this compact universal system for representing information.
And that representation system is what unlocks our ability for domain general inference, applying reasoning across different kinds of problems.
That's one influential theory. And what we might be seeing with LLMs is the same potential emerging in artificial neural networks, language as a key to more general intelligence.
Okay, shifting gears a bit to the more immediate real-world impact, where is all this AI language capability actually heading?
It's already flooding into language education for one, rapidly.
Yeah, how so?
Automated evaluation of writing, grading essays, conversational chatbots for practicing speaking, really sophisticated translation tools, speech recognition. It's becoming the expected baseline tech in that sector.
And the goal isn't just to have the tech, right? About actually improving learning.
Exactly. The focus is quickly shifting to how AI can be integrated seamlessly with human teaching to genuinely boost academic outcomes, using AI for personalized learning paths, instant feedback, things like that.
And there must be economic drivers too.
Oh, huge ones. Especially in the corporate world, B2B language learning. Companies see AI as a way to cut training costs while offering highly personalized and hopefully more effective learning for their employees.
Makes sense. What about the philosophical impact?
Well, one source puts it quite eloquently, seeing AI as an extension of the philosophy of mind.
How so?
It gives us entirely new ways to investigate different kinds of minds, artificial ones, and to explore how non-physical things, like abstract concepts or virtual machines or thought patterns, get implemented in physical systems, whether that system is a brain or a computer chip.
And that idea of emergent behaviors we talked about earlier,
Like reasoning or planning just appearing from the statistics, that's a key philosophical concept being highlighted by LLMs. It shows how complex, sometimes unpredictable behavior can arise from relatively simple underlying rules plus massive data.
thinking about society more broadly, natural language interfaces.
Huge potential there.
Hmm.
Could AI systems you just talked to democratize computational power, making complex analysis or coding accessible without needing specialized skills?
That could be revolutionary, though. It also raises questions about what happens to traditional programming expertise, I suppose.
Absolutely. And finally, there's this whole area of biomimetic AI.
Trying to copy biology.
Yeah, aiming to replicate biological functions. Maybe the brain's incredible energy efficiency or how it processes information related to emotions like valence, good, bad, or arousal, high, low energy.
And that leads to claims about AI mimicking thought or even mind reading.
Well, mind reading is probably too strong. But mimicking thought processes, yes, and potentially inferring aspects of our internal mental states from physiological data or language use in a very limited sense. It's an active and sometimes controversial research area.
It's just crystal clear from all this. AI's language leaps aren't just text specs on a page. They're shaking up multiple fields.
Profoundly, and forcing us to ask some really fundamental questions about ourselves.
They really are pushing the boundaries,
Mm-hmm.
demanding we revisit, maybe even redefine concepts we thought we had pinned down, like language, thought.
Understanding itself.
So here's a final provocative thought then, for you listening, drawing all this together.
Right.
If AI systems, just through statistical learning on vast data, can develop structures that look like the building blocks of language,
Mm-hmm.
if they can show behaviors that look like planning and reasoning, even exhibit human-like biases, and if processing information through a kind of language of thought seems to unlock general problem-solving abilities, like it might in humans,
Mm-hmm.
Does this fundamentally change how we define language, thought, even understanding itself?
Are we maybe discovering that these capacities aren't exclusively tied to biology, that they could potentially emerge in any sufficiently complex information processing system, regardless of whether it's made of neurons or silicon?
Something to think about.